How's it going, Ninth? Okay, so what I'm going to be doing is I'm going to be going through exercise 5.2, basically as like a walkthrough with you guys, okay? Right, so we have to do exercise 5.2, number 1 and 3. So number 1A. And the question is the same for all of them. It says, simplify and express each of the following expressions with positive exponents. So we've got the first one is x to the minus 8. Now remember that this is over an invisible 1, okay? And the negative is telling you it wants to be in the opposite place. So this would be equal to 1 over x to the 8. Because it's up at the top, it wants to be in the opposite place, which is at the bottom. Okay. Question B. 1 over y to the minus 4. Okay, so this one here, it's at the bottom and it's negative. So it wants to be in the opposite place, which would be the top. So this would be y to the 4. And you notice with both of these, as soon as I change its position from top to bottom in this case, the exponent changes to a positive. In this case, from bottom to top, the exponent changes to a positive. If we look at question C. Now, a lot of you will make this mistake and you will group the 4 with the A, okay? It has its own exponent. So what I want you to do is I want you to fill in the invisible exponent. So this one has a 1 there, okay? And remember, this whole thing is over an invisible 1. So the ones with positive exponents, I'm going to leave where they are. So this 4 has a positive exponent, so I leave it where it is. This A has a negative exponent, so it's at the top. It wants to be in the opposite place, so it wants to go to the bottom. So this would be A to the power of 2. And as soon as I take it to the bottom, its exponent changes from being a negative to a positive. Okay. Question D. We've got 5 over k to the minus 4. Okay, again, I'm just going to fill in the invisible exponent there. And I'm only going to change things that have the negative exponent. So 5 to the positive 1, stays where it is. Okay. Then this one wants to be in the opposite place. So it's at the bottom. It wants to come to the top. So it's k to the 4. Question E. 6 over m to the minus 5. Put in my invisible exponent. This has a negative exponent, wants to be in the opposite place, so from the bottom to the top. So 6m to the 5. Question F. We've got a to the 4 over y to the minus 5. Okay, so the a is happy where it is. Okay, it's got a positive exponent, so I'm going to leave it. The y has a negative exponent, so it wants to be in the opposite place. So if it's at the bottom, it wants to be at the top. So we make it y to the 5 to make it a positive exponent. Okay. Question G. Sorry, I just need to move up here a bit. Okay, so we've got G. X to the minus 4. Y to the 5. Now remember, this is all over an invisible 1. Okay, so the x is not happy. Why? Because it has a negative exponent. The y is happy because it has a positive exponent. So I'm going to leave the ones with positives where they are. Over. He's up at the top, this one. Wants to be at the bottom because he's negative. So x to the 4. Question H. We've got 5 over b to the minus 6. Okay, fill in our invisible exponent, so that one has an invisible 1. I'm going to leave the ones with positive exponents where they are, so the 5 can stay there. Now this b to the minus 6 is at the bottom. It wants to be up at the top because it's negative, so b to the 6. Now, great lines, I just want you to notice something here. So for example, like with this one here, I didn't put that exponent 1 there again. I don't need to, okay? Because that is 4 to the power of 1. We don't need to write it there. Likewise with the 6 here. I don't have to write the 1 there. And then the 5 here, I don't have to do that either. I did do it in this case though, just to show you that there is the exponent, but I don't have to put that 1 there. Okay, question I. We've got 4 over b to the minus 5. Put in my invisible exponent. Leave the ones that are positive where they are, so the 4 is happy where it is. This b is not happy because it's negative. Once it comes to the top, so it's b to the 5. Okay, question J. We've got 4 over 3 to the minus 1. Okay, invisible exponent. Leave the ones with the positive exponents where they are, so that's 4. Bring the 3 to the top, and it becomes 3 to the 1. Okay, now that's also got a 1 there. Now what we can actually do is we can actually work this one out. Great minds. 4 times 3 is 12. Okay, these rest of these ones we can't really work out because we don't know what the value of these variables are, and that is why we leave them as this. But this one, we know what 4 and we know what 3 is, and we know what 4 multiplied by 3 is, so we can give a final solution there. Okay. 3 times 5 to the minus 2. So what I'm going to do is I'm just going to fill in my invisible exponents. So that has that one. Okay, so leave the ones with the positive exponents where they are. And remember that this is all over an invisible 1. So we get 3 to the 1 over 5 to the power of 2. Because it wants to be at the bottom because it's negative. Now, I know what 5 squared is, so I can actually work this out, and we get 3 over 25. Question L, we've got 2x to the minus 3. Put in my invisible exponents, and over an invisible 1. Okay, so we're going to leave the ones with positive exponents where they are, so 2 to the 1 over. This one wants to be at the bottom because it's negative, so it's x cubed. Question M. We've got 2 to the minus 3 times by x. Okay, so I'm going to fill in my invisible exponents and over a secret 1. Okay, so the x is happy where it is because it has a positive exponent. So x to the 1 over. Bring this to the bottom and it becomes a positive exponent. Now I know what 2 to the 3 is. It is 8. Okay. Question N. So we've got 2x to the power of minus 3. All right, so grade 9. Remember that this has an invisible 1 there, an invisible 1. Now, remember, if you have something to the power of something raised to another power, you multiply the exponent. So this will be 2 to the 1 multiplied by minus 3. Again, something to the power of something raised to another power, you multiply the exponent. So that's 1 times minus 3. I can now simplify those exponents. 1 times minus 3 is minus 3x, and 1 times minus 3 is minus 3. Okay, so remember that this is all over an invisible 1. He's not happy there, take it to the bottom. So we've got 2 to the 3. He's not happy, take him to the bottom, x to the 3. And remember, we put a 1 up at the top like that. Okay, so now I can actually work out what 2 to the 3 is. 1 over 8x cubed. Okay, question O. We've got 1 over 2x to the minus 3. All right, so I'm going to do this one a little bit differently to how I did this one. And the way I do this, you could have done to this one. Also, I could have gone this way with this one as well. I just want to show you 2 different ways. You'll get the same answer at the end of the day. So first of all, what I want to do is I want to make this exponent positive. And now this exponent is with this entire bracket. So I need to take this whole thing to the top. And it becomes 2x to the 3. Okay. Yes, it is over an invisible 1. but I don't have to put that invisible 1 there, okay? Now what I can do is put my secret 1s there. Something to the power of something raised to another power, we multiply the exponents. Likewise with here, something to the power of something raised to another power, we multiply the exponents. So this gives us 2 to the 3x cubed, which is equal to 8x cubed. Now, the way I did this, you could have done it with this question as well. Likewise, the way I did this one, you could have done this one. It's just 2 different ways. Okay, you get the same answer, grade 9s. Right, so let's have a look at question P. So we've got 4 over 3x to the minus 5. Remember, put in your invisible exponents. So this has got a secret 1, this has got a secret 1. All right, and I'm going to leave the ones with the positive exponents where they are, and the ones with the negative exponents we're going to move. So the 4 is happy, the 3 is happy. This has got a negative exponent, so it wants to be at the top. So this becomes x to the 5. And that's your final answer. Again, I don't have to put the 1s in there. It's the same thing. Okay. Okay, where are we? Question Q. 4 over 3 to the minus 1, x to the 5. I'm just going to put in my invisible exponent, so that one has invisible 1 there. This one is happy, has a positive exponent. This one is happy, has a positive exponent. This one is not happy, it wants to be at the top. To change that, so it becomes 3 to the 1. Now, I know what 4 times 3 is. It's 12 over x to the 5. Right, next one, question R. A to the minus 6, b cubed, c squared. Okay, remember, this is over an invisible 1. I'm going to leave the ones with the positive exponents where they are, so that will be the b and the c. So b cubed, c squared. This one wants to be at the opposite place, so it wants to go to the bottom, so it's a to the 6. Okay, question S. We've got a to the minus 3 over c to the minus 5. All right, so this one we're going to do a double thing. First of all, this a wants to be at the bottom, and this c wants to be at the top. So I'm going to move the c to the top, so it becomes c to the 5. The a wants to go to the bottom, so it's a cubed. And that's your final answer. Right, we're almost done, guys. ST. Okay, so we've got m to the 9 over n to the minus 2, k to the 4. Okay, leave things where they are with the positive exponents. So m9 over k to the 4. This one is not happy, wants to be at the top, so it becomes n squared. All right, question U. 3 over 7 x to the minus 4. What I'm going to do is I'm going to fill in my invisible exponents with my 2 numbers there. So they are happy where they are. They're not going to move. The only thing that is not happy is this x. It's at the bottom, but it wants to be up at the top. So we get x to the 4. Okay, question V. We've got a to the minus 6 over b to the minus 4. All right. So again, it's going to be very similar to this question over here. I'm just going to do a double swap. He's at the top, but he wants to be at the bottom. He's at the bottom, but he wants to be up at the top. So this becomes b to the 4, a to the 6. All right. W. X to the minus 4 over y to the minus 7, z to the minus 2. All right, so this one here, very, very similar to this one and this one, but the only difference is I'm going to do 3 swaps, okay? So you can see that the x is at the top, but it doesn't want to be there because of that minus, so I'm going to take it to the bottom. The y is at the bottom, but it doesn't want to be there. So y to the 7. The z is at the bottom, but it doesn't want to be there. It wants to be at the top, so I move it, and it becomes that. Okay. Where are we? We are on x. Okay, so we've got x to the minus 3 to the power of minus 2. So with this one, I'm going to say we've got something to the power of something raised to another power, so we multiply those exponents. And now I can simplify that exponent, so we get minus 3 times minus 2 is 6. And that's our final answer for that one. Okay, question y. P to the 7, Q to the minus 4, R to the minus 3. Remember that this is over an invisible 1. The P wants to stay where it is. It's a positive exponent over. This one wants to be at the bottom. This one wants to be at the bottom. Okay, question Z, 1 over 2, y to the minus 7, z to the 5. Okay, remember, grade 9s, always put in your invisible exponents. So the 2 has a invisible 1 there. Okay, so I'm going to leave things that have the positive exponents. They want to be where they are. So that'll be a 2, and the z to the 5 want to stay at the bottom. They have positive exponents. The only one that wants to move is this y. It's at the bottom, so it wants to be up at the top. All right, so that is it for number 1, grade 9s. Let's just see here what number 3 is like. Okay, so with number 3, I think I'm going to do it in a separate video. All right, thanks, grade 9s.